Hello everybody, my name is Josh and I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business. And these lessons are all to do with trying to help you as much as possible for your upcoming A-level exams. Now, the topic that we're going to be looking at today are the Pathfinder algorithms, which is Dijkstra's and A-star. This is relevant for all specifications, but AQA, you do not have to know the A-star algorithm. Cambridge International, OCR, you do. So we'll have a little look at how to do these, and we're going to start off with Dijkstra's. I'm trying to give you as little as possible to remember because I know time is so short. And one of the things that they could, which is probably going to be the hardest question, is they're going to ask you to simply trace through a Dijkstra's algorithm on a graph, and then you to be able to go through and actually talk through what's happening at each step. So let's say this is going to be the first part where what we're trying to do is we're trying to go through A to E, and what we have to do with Dijkstra's is we have to visit every single node. You sometimes do that in A-star, but generally A-star tries to be a little bit more efficient, which I'll show you how that works in a bit. But anyway, Dijkstra's, how this works is we're going to start off at A and try and get to E. So step one is we just put all of the nodes in there, and we're just going to put A is going to be equal to 0 there. And the other ones, they have the little infinity symbol there next to it as well, because we haven't visited those yet. So remove A from the queue, and then we look at the nodes which are next to A. Now, as you can see, the weight of the line going from A to B is 7, and the weight of the line going from A to D is 3. So D goes to the front. So D's going to be the first one because it's a shorter distance. Then logically, that's the way that we're going to go for it. So if it's shorter, that's the one that you always visit first. So D goes there. So we put in for a 3 on that one, and then there's the idea of adding the distances together. Now, that can be a contentious point because some people find that a little bit confusing because they're like, well, but it equals 3. It's because A starts off as 0. With that one there, so that's why you would do 3 plus 0, which is going to equals 3, and 7 plus 0 equals 7. So that's why those values are there. We move B and D to the front of the priority queue. D is in the front because the distance is shorter. We've already talked about that. So that's step number 2 in there. So you just go to the nodes which are go next to your start node, and then you just go to the shorter one first. So we remove D from the queue because it's the next shortest space away. That's where we are in the search, and then we identify places that are connected to D. So identify the nodes that are connected, which is actually all of the other ones, which is B, C, and E. We change the values in those ones. So we're going to change B. We do 3 plus 2 because the distance going from A to D is 3, and then the distance going from D to B is 2. So that's going to give us 5, which is a shorter distance going from A, just directly from A to B. So that is why now B changes to 5, because that is a shorter distance. So that's going to take us less time to go there. C, we put in the values for that one. So going from we put 3 plus 4 because those ones they take us to C, which is going to be 7, and then E is going to be 3 plus 7 in that one there. Once we've done all of that, we're now going to remove B from the front of the queue because now we found the shortest distance because we tried 7 at the start, and when we went to D, that we found out that it was actually a slightly shorter distance there. So now we're at B, and we're now going to run some checks and see, are C and E going through this route, is it any shorter? So we look at these ones and we calculate the distances. So going to C from B is 3 plus 2 plus 3. That gives us 8. This is not shorter than 7, so we're not going to change this value. E is 3 plus 2 plus 6. So 3 plus 2 plus 6, because there's the line there. That gives us 11. This is not shorter, so we're not going to change. And then we take the C off, because obviously we want to see if actually going to C is going to be a slightly shorter route than going to E than any of the others. So again, we just run the check again. So it's going to be 3 plus 4 plus 1, or 7 plus 1, I've wrote down there, which is going to be 8. This is a shorter route then going 3 plus 7, which was 10. So we replaced that with E. So E is now going to become 8. And then we've done the search. So going through all of those different steps there is just about visiting the nodes that are connected to it, visiting the nodes, and working out the shortest possible routes. And the examiner, one of the things that I should say is, if you find a shorter route, there's nothing wrong with that. The examiner on the mark scheme actually wants to see that you've maybe crossed out that value. So you've crossed out the longer route, and then you've said this is the shorter route. So in the case of when we changed B, so the initial one was 7, wasn't it? When we were going from A to B, it was 7. So you'd cross that out, and then you've actually found out that going from A to D to B is a shorter route, so 3 plus 2. And it's just going through those steps, just visiting the nodes that are connected, and once you've done all of that, then you have found the shortest possible route to get to everywhere on there. But I mean, it was going from A to E, this one.